Okay, let's go ahead and get started. Last lecture for CSE 143. I'm going to spend a chunk of time talking about the final exam, various details about the different questions that are on the exam. Remember that I have posted resources and the exam itself, so that I've shown you kind of the set of questions that are going to be on the test. There is a sample final here with a key. You can see what's on the cheat sheet here. I'm going to show you all of that when I switch to the document camera in a little bit. The old exam question database that lets you look up old questions that you could use to practice. So what I have recommended is that you finish up Huffman if you haven't already, and then do some studying for the final, and then give yourself 110 minutes to take the final that is available here. Write your answers, on various pieces of paper. The PDF that I have here, it has space for your answers, so that should be enough if you can just print that. And then check your answers to the mechanical questions. You could take a look at the programming questions if you want to. Scan and upload it using this link here, and then have a 15-minute meeting with your TA. We want you to have taken the test and uploaded it by the end of the day on Tuesday. That's the default. I did mention that this is not a hard deadline. The B class, I think, the normal final exam schedule would be having us do our final on Thursday. Some of you might have a tight final exam schedule. If you do, talk to your TA and you could turn it in later than the Tuesday. Can't have everybody do that. We kind of have to get this moving. But if there's some of you who have a schedule that means that Tuesday is going to be difficult for you, talk to your TA so that you could make arrangements to turn it in later. We want to try to get everything wrapped up by the end of next week in terms of people taking the test and having these 15-minute meetings. For question of the day, what I always like to do at the end of the quarter is to ask people about their most favorite and least favorite assignment. So Guitar Hero was the winner here. That was kind of interesting. Very few people liked Huffman. It could be that people just aren't finished with Huffman. It may be that more people will like it later, or maybe it's just not popular. But that was kind of interesting. In terms of least favorite, Huffman had won. It had the highest number of votes, I guess, with Assassin being the second highest. Those are tedious assignments in terms of a lot of code to get right, and you can be slightly off and have a subtle bug that's hard to find and so forth. So I kind of understand why that might be so. I didn't mention this on Wednesday, so let me mention it today. You should have gotten an email about course evaluations, and there are links here in case you don't have that email still available to you. As in the 142 class, I do give a minor incentive to students to fill out the course evaluation. The students who fill it out will get a third of a homework point. So it's a tiny, tiny little bit of credit that I add for people who fill out a course evaluation. I don't have a way of connecting you to your answers, so the university just tells me who filled it out, not what they said. So don't feel that it's not an invasion of privacy in that sense. I won't know what you said. So be honest, in your answers. But there is that third of a homework point if you fill out a course evaluation, so I encourage you to do that. Okay, so I'm going to switch to the document camera in a minute to talk about the final exam and to talk about courses that you might take after 143. Part of what I want to talk about today is kind of, life after 143. Part of that also is understanding what you've learned. I often have students who come to me during office hours, and they talk to me about how they're worried because they're having so much trouble kind of, keeping up. Every week when we give out an assignment, they feel overwhelmed by the assignment. that's a common experience in general in life, but in the 143 class, I think that happens to people. One of the things that I think can be a good thing to do is to kind of reflect on, what if I gave you an assignment like letter inventory? That was our first homework assignment. What if I asked you to do that today and you had, time to work on it? People tend to say that they'd find that a pretty easy assignment. Maybe Assassin would still be challenging. Linked lists are always challenging. But I think that you would find it a lot easier to do any of those homework assignments now than you would have back then. So if we're doing our job well, we kind of are keeping you a little on edge so that we're pushing you to learn a little more every single week. And I hope we've done that. And I think that, so sometimes you should look back and kind of realize you've come a long way. You've learned a lot about this material. You've basically learned all of the control structures of Java. There's nothing left, for us really to teach you about control structures in Java. We've taught you most of the issues about data structures. There are major issues about data structures, and the most powerful built-in data structures, lists, sets, and maps. Given that combination, lists and sets and maps, you have the ability to solve lots of programming problems. We've also taught you about arrays and low-level implementation of linked lists and low-level implementation of binary trees, so you have some kind of insight into that. I'm going to say a little more when I talk about, if you go on, what would you be learning kind of in the future courses. But, you've learned an awful lot about data structures in general and about how to be a client of the Java class libraries. So kind of, what's left? What haven't we taught you? Well, it has to do with object-oriented programming. That's kind of, well, and there's computer science things we've missed too. I'll say that. When I get to talk about courses, I'll mention that. But we haven't kind of taught you all of the things about Java that are related to object-oriented programming. When I taught at the University of Arizona, I had a third course. We had a third course that students would take. In fact, Marty Stepp and I both taught that course, and it was I think a very useful course. To really master object-oriented programming, I don't think it can fit into a two-course sequence. I think you need another course that would kind of complete your education. I did teach a version of that University of Arizona course here many years ago. So in 2007, I taught a course called Object-Oriented Programming and Design. I'm going to include just a brief set of notes for today on the calendar, and I will include a link to this page in case any of you are interested in looking at it. So this is this extra course. I think maybe what's more interesting here is to look at something like the calendar to kind of see, what are the different things that are left to talk about. We haven't talked about hash code. We haven't talked about overriding the equals method. So you can kind of see various things that are mentioned here. Try catch is mentioned here, and another thing that we haven't talked about is how to do graphical user interface type programming. So there was a lecture early in the quarter for us where you may remember that I showed you, this was on the More on Inheritance lecture that we did here, that I showed you a draw frame and a custom frame. This was a class that we wrote that was using the AWT set of facilities. That's the oldest kind of in Java. That's what Java came with originally. And so one of the ideas here, one of the concepts you should be thinking about is that there are different frameworks that are available to you that allow you to create sophisticated graphical user interface programs, or nowadays web-based programs. So there are different frameworks you might choose, and these programs were written using this very old framework, AWT, that, we've been using it for our graphics, but we haven't really talked about how that user interface framework works. It was kind of easier to show you the inheritance issue there. What I teach in this course is the more, somewhat more modern framework known as Swing. The Critter tournament, the Critter Simulator, other programs you've seen that are kind of user interface that we've used in the course, those have all been written with Swing. So that's Swing was something that came later than the AWT. It's kind of a nicer framework. It's what this course is built around, is teaching you Swing. If you got interested in learning Swing, this course used as its textbook a book known as Core Java. Kai Horseman is one of the best Java teachers around, and if you really did want to kind of learn more about object-oriented programming, inheritance, kind of what haven't we covered, Core Java is a great book to use to do that. So if you got interested, you could look at that. The problem with Swing is that it's like 20 years old now. Swing is it's just, if I was learning a new framework today, I wouldn't tend to want to learn Swing because it's just so old-fashioned that people aren't using Swing all that much anymore. So I would probably, at least learn something like Android, because it's still being used. It's still kind of a more modern, than this older style Swing. But I thought I would mention it just in general, that kind of, one of the reasons that we haven't covered this material is that, in 143, is that a lot of these object-oriented issues don't become relevant until you get to very large programs. And so this course that I taught ended by having students do a programming project, a group project. And I think that was an important experience for them to have, because these techniques, these object-oriented techniques, just aren't very helpful on short 100-line programs. So anyway, if you got interested, I have lecture notes for all these different lectures. The calendar kind of shows you a set of topics that are covered. I'll mention, I don't want to spend a lot of time in terms of details, but, I would say that two areas that we have, so I guess this is a total of like 3 different areas that I'm mentioning. The framework idea is one of those areas, is that you haven't learned a framework. So that would be something that if you were going to try to learn more about Java, you'd want to learn something like Swing or learn something like Android, some framework, that provides you with utilities that do things like buttons and sliders and windows and scroll bars and so forth. You want something where somebody has written all of that code for you and you're working within their framework. So that's kind of one of the things that we haven't covered that would be left to understand. Another thing that we haven't covered is there's kind of an in-between level of protection. So we've talked about an individual class where we encapsulate things, we have private fields and so forth. So that's kind of one level we've looked at, and we've looked at public. It's a little bit like we've taught you how to behave in your house with your immediate family, and we've taught you how to behave in public. But there's kind of an in-between level that we haven't talked about, which is how a class interacts with its subclasses. So I mentioned in one of the lectures that, that there are these keywords public and private, and there's another keyword protected, which has to do with the access that your subclasses have. So kind of how to give an in-between level of access. It would be a little bit like friends and family who don't live with you, but they might have more access than a perfect stranger off the street. So there's kind of this in-between layer that we haven't talked about that you would study if you looked at Core Java or if you saw the things that I was teaching in this course here. So that's another thing that we haven't learned. And kind of, maybe I'll just mention this one minor detail. What Java does to allow you to do these user interface applications, the thing is that you want to attach a little bit of code to all of these different user interface elements. You'd want to say that when the user presses this button, I want to execute these 6 lines of code. We refer to those as code snippets, that you want to attach code snippets to individual objects. And in Java, the way that that's done is that you can create little anonymous classes, that you can have kind of a little bit of code that constructs a really simple object that's just got those 6 lines of code in it, and it's attached to, say, a button, so that when the user presses that button, this object that we constructed executes. One of the ways you know that these things exist is that when you have these little anonymous classes in Java, they generate .class files that have $signs in them. So you may have noticed that when you compile Drawing Panel, which Marty Stepp and I wrote, it produces not just Drawing Panel.class, but a whole bunch of other things that are $.class. Those are all those little anonymous classes that are inside of Drawing Panel. So if you ever wondered what are all those little $sign things, this is something that we haven't covered, and I'm not going to try to cover it in 2 minutes. I'm just kind of letting you know that the topic there is what's known as anonymous classes. It's described in core Java. It's mentioned in here. There's lecture notes if you want to read about it, in here. But that's something that's kind of we haven't covered. But that's not a lot. We've covered a whole lot of things. You have a pretty strong mastery of Java. Little details here and there, the object-oriented stuff we haven't covered as well. Let me mention one other thing. I think I mentioned it briefly at the end of the last lecture, but I wanted to mention it again. So the Java source code can be something that's interesting to look at. I often turn to the Java source code. The source code in these newer versions of Java, the source code just keeps getting bigger and bigger and more complicated. I kind of liked the Java source code as of Java 8. And so what I'm going to include in that notes file for today is a little link. If you wanted to download the Java source code for Java 8, I'll include a link to that file. But you'll find, so it's, there's a src, it's short for source.zip, that has all of this in it. If you have a Windows machine, if you go to your program files folder on your main drive, like your C: drive, and you open that up and open up a folder called Java, you'll find a JDK folder in there that has src.zip in it. So you probably have the Java source code on your computer already. But as I say, these kind of later versions of Java, I think the source code has gotten rather complicated. So I kind of liked it as of Java 8. So what I'm going to have a link to in those notes that I'll put up for today is an src.zip, source.zip for Java 8. Let me go ahead and open up this folder just to kind of tell you how you can use this resource. So suppose that you wanted to look at something like array list. Well, you know that it's in the java.util package. So the way you find that here is by opening up Java and then opening up util. If you do that, you'll see that we've got abstract collection, all those abstract classes we talked about. There's ArrayList.java. So that's within java.util. Suppose you wanted to look at the string class. That's part of a package called java.lang that has very important Java features. You don't have to do an import of java.lang. It's done automatically for you. And so we could open up java.lang and see all sorts of stuff that's in here. And included in here is the string class. So so we can kind of take a look here, and see how the string class is implemented. Lots of Java.doc comments. I think I mentioned at one point in time that it's a final class, which means that Java does not allow you to create a subclass of that. It implements comparable of string, if you looked in here, you could kind of see the fields that are used for a string. If you wanted to do something like, I don't want to do a find on the comparable. How about if I do a find in here? What if you were interested in something like how the compare to method is implemented? So what if we did a search for compare to? That's kind of a little documentation thing. Here it is, the compare to method. So if you want to kind of see what code they wrote, in the compare to method for strings, so it's supposed to return a negative integer to indicate a less than relationship, a 0 if they're equal, and a positive integer if it's a greater than relationship. Well, what the string class does is it goes through two character arrays, a character array for this string and a character array for the other string, and it's looking, it compares the first characters of each, and if they're the same, it goes to the next one, and if they're the same, it goes to the next one. If they're the same, it goes to the next one. So it's looking for two characters that are not equal to each other. It's looking for a pair of characters where there's a difference. Well, so like if we use the example of Biden and Trump, and so it finds a difference right away between the B in Biden and the T in Trump. And if it finds that difference, it returns the difference of the two characters. So it would return the ASCII value of suppose that you were asking the Biden string to compare itself to Trump, it would do the ASCII value of a B minus the ASCII value of a T. So that's what it would return if it finds a difference in the characters. Now it might find that it has two strings that are like Trump and Trumpism, where there aren't characters that are different. You run out of characters in one of the strings, and in that case you return the difference of the lengths. Whichever string is shorter is considered less. And so that's our trick, that we've talked about, kind of the subtracting the two ints as a way of having a value, that you return from a compare to. So if you're interested, you can look that up and kind of see the Java source code for how compare to is written for the string class. So I do that kind of often. Some of what you're going to come across you won't entirely understand, but don't worry about that. The parts of, there's a lot of it that you will understand. And you might find that interesting then to be able to see how some of these built-in things are implemented. Okay, I'm going to switch to the document camera. Let me send that to the projector to try to make sure we're looking at the same thing and bring that up. Okay, well, I want to start by talking about the final. So what I did for the midterm was that I had made a little spreadsheet that lets you see scores of old exams, for the different questions. And I kind of went through question by question. So I'm going to do that here as well. The test that we're using as the actual final is this one here, that had an average of 71.7. A little lower, a little harder than I like. I usually aim for a 75, but pretty close to what I'm aiming for. This is the sample final, had this average here, and I think this is the one that the section problems were based on, this exam here. But this is kind of, you can see the history of these different things. So the binary tree traversal, you can see scores are high on this, which is good. The sailboat approach, is perfectly fine for doing the traversal. The binary search tree, we give you a set of words or names and ask you to show us the binary search tree that you would get by adding them in that order. I think this is something that people are pretty good at doing. You probably don't need a lot of practice, but if you wanted to, in the binary search tree lecture, you can download my little tree.jar program that lets you practice this. If you wanted to, you could do that. This one, what I would say is that the problem we had, in terms of grading, the reason that the scores are a little lower is that when people make a mistake, it's hard to give partial credit. So, if this were the normal quarter, I'd be asking you to be very careful. There's a thing I've seen people do, which I think is an interesting idea, which is that they'll kind of write down A, B, C, D, E, F, G. They'll kind of write out the alphabet, because I think part of the issue is you just forget the alphabet. That's the mistake you might end up making in that particular problem. Collections mystery, this is a pretty low score for a mechanical question, for a mystery style question. I'm not entirely sure why that is true. What I tend to do with this collections mystery question is that I tend to do a 2D array bit of code. So I asked the TAs to cover that in section last week. I didn't have time to do 2D arrays in class, but it is something that I include in this mystery problem on the final. Basically, I want you to be able to read code that involves a 2D array. I'm not going to ask you to write code that involves a 2D array, but I want you to be able to read the code that involves a 2D array. And then usually there's might be some other kinds of collections involved, a tree set, for example. I would want you to remember that a tree set keeps things in increasing order. If they're numbers, they're in numerical order. If they're strings, they're in alphabetical order. And it eliminates duplicates. I'm always kind of surprised on a question like this when someone doesn't seem to remember that one of the properties of sets is that they don't allow duplicates. So if you put the same number into a set 5 times, there's only one occurrence of that number, not multiple occurrences of that number. So collections are something that would be worth reviewing. There's a bunch of these available as little problems in the old problem database. You could even copy the code, from it and put it into JGrasp and run it to kind of check what the answer is. Or you could do a collections mystery, take a look and practice it to see what questions are available there. But that's a little disappointing that the average there is that low. And then collections programming. So collections programming, some of the kinds of things to remember, as I said. So the cheat sheet mentions it kind of mentions lists, sets, and maps, and it reminds you of the different implementations of those things. So for sets, remember that tree set keeps the values ordered. Tree maps keep the keys in sorted order. Hash set does not. So often in a problem statement, I might say something like, I want the numbers to be in increasing order, and if the numbers are going to be in increasing order, it has to be a tree set and not a hash set. So sometimes in these questions, like this 5-point collections programming question or this 10-point collections programming question, I won't say whether to use a tree set or a hash set because I'll give you some other information that would have you be able to figure out whether it's a tree set or a hash set. So if I say that the values should be kept in increasing order, then you would use a tree set. If I mention that the keys should be in increasing order, you'd use a tree map. When I have an audience, I usually ask people, what would be a situation where you would know to pick a hash set or a hash map instead? Well, if you're gonna be using a set, for example, then you can only use tree set if it's values that implement the comparable interface. Strings implement comparable, integer implements comparable. So an awful lot of things that we've seen implement comparable, but there's one thing on this cheat sheet that doesn't implement comparable, and that's the point class. So you'll see that in these collections questions, I might in this 5-point question, for example, ask you to make a set of point objects. And if you're going to make a set of point objects, it can't be a tree set because point does not implement the comparable interface. So you would be forced to use a hash set because you have to for things that do not implement comparable. And the point class does not implement comparable. That's one of the reasons that I include the point class on the cheat sheet so that it's something available to me for these collections questions. Another thing that comes up in the collections programming is that, we've talked about this several times, but if you are using an iterator to traverse a set, for example, and you want to remove things from the set, you have to talk to the iterator to do the remove. You can't kind of have the iterator show you a value and then you ask the set to do the remove because that gets a concurrent modification exception. So the way to remove things using an iterator is to ask the iterator to do the remove. So if that's something that you still haven't quite gotten, that's something to review, before the exam. It'd be worth a point or two on the actual exam if you ended up making that mistake. And even worse would be if you had a for each loop where you were trying to do something like a remove. Remember, for each loops are a read-only operation. So if you want to traverse something just kind of examining the values, then a for each loop is perfectly appropriate, and then it's good to use the for each loop on these questions because it makes the code simpler. You're more likely to get it right. But not for changes, not when you're changing the underlying structure. There are 2 binary tree programs that I'm going to include. So a 10-point question and a 20-point question. We kind of had 2 different sections where we went over binary tree questions. You can go back to the Sections tab on the course webpage and take a look at the questions that we did. There was a Tuesday section where we did a bunch of old 10-point questions for binary trees, and then a Thursday section where we did a lot of 20-point questions. So the 10-point questions tend to be something that can be done with a traversal, that we don't generally ask you to change the structure. For both the 10-point and the 20-point question, you're going to end up with a public-private pair. So that's something that we would want you to keep in mind, is that there'd be a public-private pair of methods. And I've said this many times, but often the key to understanding how to solve one of these questions is to figure out the parameter passing. Now, since you're going to be writing the private method, you get to determine whatever parameter passing you want in that private method. So, there might be an extra parameter that keeps track of what level of the tree you're at. Or some of these problems involve a sum of values, coming from the root. So there might be a parameter that tells you about the sum. There are all sorts of things that you might kind of be keeping track of as an extra parameter. What I had said when we were first doing this is that one of the things to be thinking about is think about how you would solve it without recursion. Just think about what kinds of operations you'd perform. And if you kind of are thinking to yourself, well, I have to be computing a sum as I descend the tree, that's kind of the clue that you want this extra parameter. In the case of, if it were an iterative solution, we'd just declare a local variable that would keep track of something like that. But ever since we first saw that problem that I showed you where we were trying to find the sum of values in an array, and I had pointed out that we want an index, as an extra thing to be able to manipulate, that we see that in the recursive equivalent of that is to introduce extra parameters. And obviously you can have as many of those parameters as you want. So the 10-point question tends to be something that would be a traversal. Sometimes there's something to do before the recursion begins, and sometimes there's something to do after the recursion is over, in which case the public method is not going to be a one-line method, because there'll be a line of code in there that calls the private method to get the recursion started, but there might be extra things to do before that call or extra things to do after that call. So you kind of want to be familiar with that pattern as well. In terms of the 20-point question, it is often the case that to solve the problem well, we want you to use x assign change x. So that's something to keep in mind. If that's part of what we're testing here in that 20-point question is whether you've mastered the x assign change x form for manipulating a structure. A lot of these things are really difficult to try to write if you don't do it in the x assign change x way. For one thing, there are 3 different places where you would end up having the code, because you might need to change overall root, you might need to change root.left, and you might need to change root.right. So you tend to have 3 times as much code if you're not going to use x assign change x, and sometimes it's even worse. Sometimes instead of an if, you need a while, and there's all sorts of tricky cases to get just right. So x assign change x is definitely something that simplifies a lot of these. You could look at those questions from that Thursday section. There is a key for those questions on that Thursday section, kind of the second binary tree section. So that's a great resource for you to review. Let me mention a little something about the binary tree versus linked list, which is I am trying with an exam like this to come up with some kind of a balanced exam. I used to kind of trade off that sometimes I'd make the binary tree question particularly hard, sometimes I'd make the linked list question particularly hard. I reached a point where I decided that it was not good to make the binary tree question particularly hard. Because often what ends up happening then is that you need an insight about the parameter passing. And if you don't have that insight, you get almost no credit. Basically, you're just not anywhere near a working solution if you can't figure out that parameter passing. It's a little too all or nothing, in terms of grading. So what I've been doing in recent, exams is having the binary tree question be somewhat more predictable. It also means that I reuse a lot of old questions. So you might find that very helpful. That you might find that if you study some of those questions that are in that Thursday section, you may find that one of them is on the actual exam. Because I do often reuse old exam questions, and particularly for the binary tree. But it's the linked list question where I'm kind of willing to make it particularly hard. I guess the reasoning I have for that is that linked list code is tedious, but anybody can learn how to do linked list programming. Anybody can learn how to draw the appropriate, pictures to kind of figure out what's going on with the code that you're writing, the .next that you're doing. And so it seemed like if there's going to be a question that's particularly hard, that's where I'd want it to be. But let me save that for a little bit. I'm going to say some things about that. I think I didn't look at the averages here. Let's take a look. Collections programming, 81%. The harder collections, 72%. So these questions are challenging. Not surprising. I guess that collections programming had the 72%. The easier binary tree question was an 80%. The harder binary tree question, 76%. So, pretty strong scores in general. The comparable class, that's where I ask you to write an entire class. So I want you to be able to show me, so the only time I think in all of 142 and 143, well, I guess we had a critter question on the 142 file, but I'm asking you to show me a complete class with fields and constructors, and there might be getter methods that you have to write. There's often a little tricky thing about, getting something just right in terms of like time, for example, and having, two-digit time, is one of the tricky things that I had in one of those problems. I tend to reuse old comparable class questions as well. And you notice, 80% just about on that. So scores are relatively high because, there's a lot of details to get right, and people screw up some of the details, but they tend to get most of the details right. The one that has the lowest average score, so that one really stands out, doesn't it? The linked list question with an average of 49.9. Actually, there was a quarter where I first mentioned to people that I was definitely going to make the linked list one particularly hard, and I thought that might be the quarter that everybody studies more, and suddenly these scores are higher, but it just hasn't happened. Look at it. It's a 20-point question. Look at the history of what I've gotten here. Like the highest average I ever had was an 11.8. So these questions are hard for people. I mean, what it tells me is that there are people who still haven't mastered linked lists. Now, maybe you're going to decide that because this quarter we're not grading the contents of your answer, you'll just kind of live with that you don't know how to do linked lists. I do think that it's good for you. It's good to kind of practice these and try to reach a point where you can solve these kinds of questions. Often with these questions, in terms of the grading, I have a fair number of points for short lists. So, there might be a point or two for whether it works on the empty list. Does it work on the 1-element list? Does it work on the 2-element list? Does it work on the 3-element list? So I think even just kind of simulating your code For those very simple cases, 0, 1, 2, maybe 3 elements in a list, it's good to try to make sure your code does the right thing in that particular case. And then, of course, you want it to be general enough, some kind of a loop that allows it to solve problems that involve longer lists. But I'm surprised sometimes that people don't even have code that works on the shorter lists. So it's essential to be able to draw pictures of what's going on, to be able to simulate your own code. Remember, there's only 2 ways to change a linked list, which is to change what the front refers to, or to change one of these .next fields, where that's a .next, of one of the nodes in the list. So if you're not resetting front to something or resetting .next to something, then you're not rearranging the links of the list. So practice helps a lot. We had a bunch of these harder linked list questions in an earlier section. We had a few more even in Tuesday's section this week. So there's a lot of sample problems available. And this quarter, that's not normally true, but this quarter, all of those section problems have a key associated with them, so that you can kind of take a look at that as well. We have a bonus when we do a regular exam. I did not include a bonus for you guys for this particular test, since we're not grading it in the normal way. Again, a reminder that the cheat sheet is helpful, kind of as a set of things to study. You are limited to the things on the cheat sheet, so you're not allowed to use things that aren't here. Okay, well, that's kind of what I wanted to say about the test. I want to use the last bit of class time here then to talk a little bit about courses, kind of what's left that you haven't learned. Maybe I'll say a few things about languages first. So, we've been studying Java, and Java is still a major language. It's, one of the most common languages that people offer jobs for in industry. So it's useful to know Java. An awful lot of companies know that colleges teach Java, and so even if they're going to have you use something else, they're willing to hire you if you've mastered Java. And remember, the core syntax for Java and C and C++ and C#, all of those languages have the same, while loops, for loops, type int, there's arrays. There's an awful lot of syntax that's in common between these things. But C, C++ is kind of another area where it would be useful to study. This is C and C++ have traditionally been used more in system-style programming, in graphics assignments. Graphics programs tend to be written in C and C++. C is something that allows you to kind of write more low-level code. Someone had described C as their favorite high-level machine language, that it kind of lets you do very low-level style things that are often done in systems courses. Well, like asking for the address of something. Java doesn't let you ask for the address of something. C and C++ do. I put them together because C++ is a superset of C. So, when you study C++, you end up learning a lot of C along the way. Python is becoming increasingly popular, and particularly among the people who are doing what we call data science. So people who are dealing with very large data sets that they want to manipulate. It's actually not usually Python that's doing the actual data manipulation. It's a framework again, not a framework for user interface, but a framework for doing data computations. And Python is being used more as the glue that allows you to work within that framework, to kind of submit things to the framework. So Python is becoming increasingly popular. A lot of engineers need to study MATLAB because MATLAB is still very popular. Although I've been surprised, a lot of the engineers are switching to Python from MATLAB. So I would say that this is kind of dying out in favor of Python. Object-oriented programming, so there's still a lot of Java, there's still a lot of C++, but I would say that industry is a lot less happy with these languages than they were before. Object-oriented programming just hasn't turned out to be quite as helpful as we thought it would be. Well, let's talk a little bit about, so you guys have done the 142, 143 sequence. There's kind of, I'm going to talk more about non-majors courses. I assume that most of you who are in the major have had the advantage of advising with our own advising staff, and so you know what's relevant to you. So I'm going to mostly be talking about the non-majors courses here. But if you want to kind of continue what we learned in 143, 373 is the non-majors data structures course. So I mentioned that this kind of picks up where we leave off. They're going to teach you about balanced binary search trees, a better understanding of hashing, other kinds of data structures and algorithms. So that's kind of the theme of 373. It's very similar to a course for majors, which is 332. So there's a lot of overlap between the non-majors course and the majors course. For those in the CS major, you don't go directly from 143 into 332. You probably know by now that you take a course 311, which is a math course, basically. We want to teach you a lot of mathematics that's used in computer science, and we want you to do that before you go into the 332 course. So for CS majors, a next course they're going to be considering, for a lot of people, is going to be the 311 course, which kind of teaches you the math part of it. We don't really offer that as a non-majors course. We've thought about it, but math is not all that popular, so maybe people wouldn't be quite as interested. There's a strong overlap with our 311 course and what the math department teaches in their math 300 course. Marty Stepp, many years ago, he and I worked with people at Google, actually. We got grant money to create a course 154, which is web programming. I didn't kind of include, I should have included, let me put it here, JavaScript. I should have included that here. That JavaScript is an important language, in the web programming universe. So basically, this course we created to teach people things that they would need to know if they wanted to understand how to create web pages, how to program for the web. This course is the course that when we survey our alums, they say this course was the single most useful course for them, the web programming course. So that's a course to consider. I think it's a great course to take. 163 is basically a Python data science course. A lot of people take the 160 course beforehand, but you don't need to do that. If you've taken 142 and 143, you can just go right into the 163 course. You don't know as much Python, but there's a lot of people who are picking up Python early in that 163 course, so I wouldn't worry about that. That's so if you're interested in that aspect of stuff, 163 is a very useful course. We teach a course 374. It's kind of an old-fashioned course for us, but it's basically C, C++. There's some C, C++ material in there. Mostly the ECE students take that 374 course from us. And then I'm going to include a link in the notes that I put for today for the non-majors courses. But there's a lot of upper division courses. Machine learning is kind of the new hot field. Databases are really very useful. I've made lots of money consulting by doing database programming. Programming languages is a really interesting course that teaches you even more programming languages than what I've mentioned here. So there's lots of courses that we offer at our 400 level. I've only included a few of them here. You usually have to take 373 before you would take any of those courses. Check it out. I mean, as I said, it's on the class webpage, but I'll also include the link in the notes for today, this list of non-majors courses. You could put together a pretty interesting group of courses, given what we offer for the non-majors. I've thought about teaching a course in C++, and there's some possibility that I might offer it next year. C++ is a very complex language. There's a lot to teach, and it kind of deserves its own course. So at some point in time, maybe I'll teach a course on C++ to prepare people who are going to be doing that in industry. So keep an eye out for that, or send me an email if you want later and ask me whether or not I am offering that course. Well, we've kind of run out of time, so please fill out a course evaluation. Third of a homework point, incentive for doing so. I've had a great quarter. I hope you guys did too. Good luck on the final, and have a great summer.